All right, thank you, Ross. Test first. It's not just another TDD lecture, or you all hope it's not. Anyway, so speaking of TDD, who here loves TDD? And I'm going to scan the crowd and call out the liars that I know doing it. Who here, yeah, Scott, I saw your hand go down quickly. Who here likes TDD? Who can tolerate TDD? There's a lot of hands still not up. There's a lot of people wishing they'd gone to the talk next door, potentially. All right, so personally I love TDD. It's something that I follow whenever I can. And sometimes, I guess I'm a bit of a purist with it as well, and sometimes it can get me into trouble. So for instance, we were in the office a while ago and we're talking about what makes the principles of good engineering, like what are some guiding principles we live by. And of course, when we got to testing, I piped up and started saying that, well, we should all be doing TDD. I was met with a little bit of resistance, which initially sort of took me back, but I eventually showed some pragmatism, which was really hard for me, but I did it. And after a long discussion, we kind of agreed on this terminology of, well, we don't have to do TDD, but we should be test first. And it's like, well, what is test first? And I thought that makes a good blog post, and that potentially makes a good talk as well. So TDD for me, so what is test first? I've already slipped up and mentioned TDD again. So test first for me is where essentially you are planning and incorporating testing into your process as early as possible. So traditionally we leave it as a bolt-on process at the end that's somebody else's responsibility, but it's something we really should be bringing back and making part of our process. I know I'm sort of talking here that we all know this stuff already. But whilst you don't have to do your tests up front, you don't have to write all of your tests up front, you don't have to do TDD, you still need to know from the very start, how are you going to test your stuff? How do you know you're going to be building the right thing? And how do you know you're going to be building the thing right? Because they are two very different things. Cool. Who here has seen this diagram before? Anyone who's been to one of our sessions would have seen it? Yeah, a few people. So the x-axis is the time the defect is found. Does anyone want to have a guess or anyone know what the y-axis is? Yep, so the cost to rectify. So specifically, the cost to rectify a defect grows exponentially with how far into the process we find that defect. So if you find a defect right at the end of your process, it's going to be the most expensive to fix. So why don't we find them at the start and rectify them then? Cool, all right, so why test first? So why specifically did I choose to talk about this? Because really it's a pattern that we still keep seeing over and over where people are leaving their testing till the very end of the process. It's a very common pattern, and I think we keep falling into the same mistakes, and it keeps tripping us up. We keep seeing it over and over again. But there's some really simple stuff here, and as you'll see during this presentation, nothing here is groundbreaking, nothing is stuff that I've invented. It's just a bunch of really simple stuff, and there's a lot of ways we can shift left in software testing, and so realistically, we should be doing it in all of our projects. I'm going to kind of go through some of those today. All right, so I did say it was not a TDD lecture, but I am going to start with TDD as the first thing. So like I said before, I love TDD. The whole red-green refactor thing is just something that sits with me really well. So I hope we all kind of understand traditionally why we do TDD. So I think the main reason previously is because it builds a regression suite as we go. So if we write our tests before we write our software, or whilst we're writing our software, we're building up this regression suite so that we can then refactor our functionality at that time or sometime in the future, and we've got a regression suite to go along with it. There is something much more than that though, and that's the ability with TDD, and I think this is the one that we often forget, is that we can use it as a tool to clarify and refine requirements. So let's take a bit of an example. So the product owner has given us a requirement, which is that account holders get a discount when the spend is over $100. So the team go off and write a test for that, and as you can see, we're testing basically simple stuff that a 10% discount is applied as we go. And then the beauty of this now is you can then take this test and show your product owner. You might be circling it with the team, it might be in a session where you get looking at the requirements, and you can show them the test and say, this is what we're going to build the software to. This is our specification. Of course, when you show the product owner, they might pick up on that, and that discount to on the previous one was quite a scary number. So the product owner might pipe up now and say, well, hang on a sec, I can't just go throwing away cash. Hence, a second requirement is brought out. The maximum discount will be $100. The team then take that requirement and go and iterate on the test. So because they've learned something new about the requirement by writing the test and taking it to the product owner, they can now change it. So they've changed that logic. Yes, this is a very simple example of a very simple function, but we've iterated on the requirement, and we're now building it into our process at the very start. All right, so not really saying anything new here, but my key aim here is that when applicable, because we know it's not always applicable, you should consider TDD, because it's not just about writing tests, it's about making sure we understand our requirements from the start, and it's often something that we don't think about with TDD. All right, but what if we can't do TDD, Andrew? What if we won't do TDD? So there are scenarios where it happens. We might be building, as I think it was mentioned earlier, about building a proof of concept, and you just want to get something out to the market as quickly as possible. You might be building something that's super UI heavy, and TDD just doesn't really seem to fit. But don't worry about it, Andrew. We'll add unit tests later on. What happens to later? Later never comes. But perhaps the one that gets me the most is this second one here. It becomes too hard to add unit tests later, so the team go and build their code and architect their code base, and then come back later on and go, actually, it's really hard to add tests in there now. We can't really do unit testing because we've gone down a certain path. Like they might have mixed up their business logic layer with their database layer, and now it becomes really, it becomes too hard to add tests. So that is actually one of my pet hates, is that second point there. We can get around this really simply. So even if you're not going to do TDD, my one ask is that as you're building functionality, just write one test. And it can be the simplest test in the world, but it will ensure that you design your software and build your software with unit tests in mind, so that later on when you do or want to go back and add unit tests, you know that your tech stack supports it because you've got the libraries in there from the start. You set up your testing library, and you know that your code is structured in a way that will allow you to add it. All right, so designing your system and test first. So yeah, I'm a massive believer that you should structure your code to facilitate your unit testing. People often think that I should write my code in the way that makes the most sense of my code, and if I can unit test it, I can. But I'm a big believer that architecting your code to support unit testing is a really, really positive thing. All right, Andrew, we're just not going to do unit testing. So we've decided that in our system, unit testing is just not the thing for us, and we're not going to do it. And that's okay, we can still be friends, but I do ask that you still consider some kind of testing. So everyone here hopefully remembers our good old mate, it's gone missing these days, the testing pyramid, which says that you can have many unit tests, a few integration tests, and very few end-to-end tests because they're expensive to maintain, they're expensive to run. It's still a thing, and that's giving you 3 layers there for where you can choose your testing approach. So what's this got to do with test first? So test first doesn't mean that you have to write all of your tests up front, but it does mean you should sit and agree on a strategy before you write any code. So I'm quite happy if a team that I'm running turns around and says, we're not going to do TDD, but if they can say a statement like this, it shows me that they've thought about it. So we're not going to do TDD, but we will add some unit tests for the calculation logic. We'll add some API tests to cover security, and then we'll do a couple of basic end-to-end tests at the end to cover the 2 or 3 major user flows. So this statement shows me that the team, although they made a conscious choice not to do TDD, they have decided that they will, they have got a strategy, and I can quite clearly tell that they sat down and thought about that strategy before they set about doing any code. So automation just isn't for us. So you will get teams where automation is just not a thing that they're going to do. So this could be a scenario where there's a manual QA department, they've already been funded, they've already been paid for, they're already incorporated into the project, and they're the ones who are going to do the testing. But that's okay. And I think what you realize with test first, you can still shift left by strategizing your manual testing approach. So it doesn't have to be automation to become a test-first team. You can still build testing into your process in the early stages using manual testing. So to highlight this, I want to just step us through the typical life cycle of a Jira ticket. So essentially with the Jira ticket, what happens is the developer finishes the ticket and creates a PR because they're finished with it. They then, sometime later, it gets merged into main and the developer moves it to review. So this might be 2, 3, 4 days later, depending on how quickly the team does the PR. And then sometime later again, the separate QA team pick up the ticket and they start testing it and they find a bug in the first 2 minutes. It drives me nuts when that happens, and it happens a lot. So the problem here is that since then, the developer has moved on to the next ticket. So they've gone off and basically said, well, I've finished with that piece, I'll move on to the next one. So they've moved on. And this cycle just continues over and over again. So what if I told you that you could still be test first and you can still shift left with a manual testing approach? So this is just one example. And the example I've chosen to use here is DevBox testing, which was a tool I was exposed to at a previous project that I believe worked really well. So DevBox testing is a scenario where a developer at any stage, they don't have to be finished, they could be just starting out on the functionality, invites another dev or a QA to their machine. Yes, you will have to sit with another person at your machine and code and pair with it. But basically, they get them to test the feature. So what they might do is they might run through the acceptance criteria, assuming it's all documented on the Jira card and the developer has actually read it before they've gone off and built the functionality. And then they might do some free play testing, like say, okay, so all the requirements work, but what happens if you completely smash that field with 600 characters? What happens if you leave this form empty? What happens if you do that? So it allows them to do some free play testing. The dev, and I've said here, the dev fixes before pushing the PR, because I find it highly unlikely that they won't find any bugs doing this scenario. But essentially now the dev has got an opportunity to fix all of the bugs before pushing the PR. So they've shifted that feedback all the way along that x-axis right back towards the start, rather than waiting for the QA to pick it up days, weeks, or a month later. So why is this a test-first approach? So DevBox testing is arguably the most effective way I've ever seen manual testing incorporated into a team. And the only reason why is it's because it's done in collaboration. It's done at the point of change with the developer, not at some stage later on. So like I said before, I've chosen DevBox testing as the example here. People could investigate their own ways of bringing manual testing into their process. I'm sure there are many other ways which it can be done. Okay, stepping even further along that x-axis again, even before you write any code. So example mapping. So some people might know about example mapping. There is a really good blog post out there by a really talented guy. I can send around the link later on. But example mapping is essentially a technique that you can use to derive requirements. Example mapping, you use different colored post-it notes to to specify stories, you specify business rules. You can provide examples with green cards. It does look a bit yellow on this screen, sorry. And then questions with the red cards. So this is an activity that is done around a table with the team, product owner, developer, tester, as many of the team who's available. And essentially what it allows you to do is go down and derive a requirement and start coming up with your business rules. For instance, here we've got a similar one to before in that discounts are offered on the previous month's spend in the store. And there are some rates there for where the discount rates are. And then our clarification around the $100 cap. The team then ask a couple of questions about this, like for instance, is this in one spend or can it accumulate over the month? Is it based on the previous month's discounted spend, etc.? So you can see the team are really starting to think about this and ask the product owner these questions before they've even written any code at this stage. That essentially translates down to this scenario. And it is a little bit hard to read here, but one of the examples here is, for instance, Bart spends $30 in January. In February, he shops and he spends $20, and he gets a $1 discount for a total bill of $19. So we've gone ahead and we've actually really clarified it with an example. Gets a lot more complicated examples as well. There's one where Homer continuously keeps returning back to the store and spending more and more money and hits the $100 cap. For those that are wondering, this is built off a virtual Quickie Mart from The Simpsons. So what have we done here with regards to these green cards? What have we formulated here? We've kind of already got our test cases with the blue, and now we've got our test data with the green cards. So before we've written any code, we've already gone ahead and started writing test data. We can then take this data from here and that can form test inputs into our TDD, if we are doing TDD, into integration tests or end-to-end tests, or could simply just be used for that manual testing in DevBox testing later on. All right, so why am I going on about example mapping so much? So essentially it is a really good technique that allows you to formulate a list of test cases and data for the developer and tester to work with. So there's that collaboration again. You're building a common understanding amongst the team. So bringing back the product owner and saying, is this really what you mean by this requirement? Before we go and write this code, can we confirm that this is how you want the system to behave? So yeah, we're testing our understanding of those requirements. And we're testing before code has even started. We're basically testing, are we going to build the right thing before we've put pen to paper and actually even started writing any code? All right, so bringing back our exponential curve from before, where do these things sit? So typically a UAT cycle that we all know and love sits right at the very end. We find defects in UAT, it's really expensive to fix. So if we look at some of these other techniques, TDD, right back down near the start, if we find bugs in TDD, pretty cheap to fix, the developers, still developing the code. DevBox testing and other manual techniques like that are pulled into our process whilst a little bit further along the x-axis, still occurring at a time where fixing those defects is very cheap. And then example mapping, which is right back along the x-axis before we've even written any code. Like, can't really be much cheaper to fix than that. So the key point I wanted to highlight with all of this is, regardless of what testing you use, like I said, I love TDD, not everyone loves TDD, but there's all those other tools from the testing pyramid and whatnot. Regardless of what we use, the time to define that and the time to implement that into your process is right back at the very start, because you need to get that into your process then. If you don't do that, there are some serious repercussions. For instance, you could have architectural mistakes, integration issues, poor user experience, angry product owners, we've all seen that, budget blowouts, and untestable code. You will end up architecting your code in a way that will not let you build testing into your process. So the key point, you don't have to do TDD, but you really need to know how and when you're going to test your functionality before you even start writing any code. I finished with 30 seconds to spare. Thank you.